Hi guys, this is Miss Scott, and today we're going to cover section 7.1 in geometry. Here's your bad joke of the day before we get to that. Why are cats bad at video games? They can only press pause, so that would make it kind of difficult to be good. Okay, so let's jump into this. Now, just kind of a tip, a lot of what we do in this lesson you're probably already going to know how to do. So if that's the case, feel free to pause at any time and give these examples a try, and then you can fast forward and see if you did them right. So if you want to pause now, you can jot down our essential question, so go ahead and do that. All right, and the essential question tells us that if you know the lengths of two sides of a right triangle, so today we're going to focus on right triangles, how do you find the third side? And one thing I'd like to point out in the Pythagorean theorem is you've probably heard a squared plus b squared equals c squared before. Just know that that a and that b are the legs, and then c is always the hypotenuse, and this only works for right triangles. So, kind of the long version of the Pythagorean theorem is a leg squared plus a leg squared equals the hypotenuse squared. And the hypotenuse is always the longest side. And we don't like to write all that out all the time, so in math we use variables to make life a little bit easier. Now there are a set of special numbers called Pythagorean triples, and those are just three integers, so whole numbers like 3, 4, 5, for example, that satisfy the Pythagorean theorem. So they work in, or they satisfy a squared, oops, this doesn't want to work, a squared plus b squared equals c squared. All right, and there's a whole set of numbers that do that. If you Google Pythagorean triples, a lot of information is going to come up. You'll probably find a table that has some of the common ones in it. All right, so let's look at some examples. We are going to find the missing length in the right triangle given the information below. All right, so in number 1, if they give me a leg of 12 inches and a leg of 9 inches, that is the a and the b that we can plug into the Pythagorean theorem. So we are going to solve for c. So we'll say 12 squared plus 9 squared equals c squared. If you add 144 and 81, that gives you 225. So c, if we take the square root, we can get that by itself. And the square root of 225 is 15. So that would be our answer for number 1. All right, now in example 2, notice that they give us a leg, so we can call that A, and the hypotenuse, which has to be C. So in this case, we're going to solve for one of the legs. So for A, let's fill in 3.5 squared plus B squared equals 12.5 squared. And 3.5 squared ends up being 12.25 plus b squared equals 12.5 squared is 156.25. All right, now what we need to do is subtract that 12.25 from both sides so we can get b by itself. So these cancel, and we end up with b squared equals 144 is what you get when you subtract those. And if we square root both sides, we'll get b by itself, and it ends up being 12. So that worked out kind of nice. All right, now this last example, notice that I have radicals or square roots on my triangle, but we're still going to set this up the same way. So we'll say that this square root of 7 is a. They're using x for this b here, and then the square root of 19 is c. So if we fill in, we have the square root of 7 squared plus x squared is equal to the square root of 19 squared. Now you don't really need to plug the square root of 7 squared into a calculator or anything, Because if you look over here, well, remember to get b by itself, we square rooted b squared, and then those canceled out. So we ended up with just our answer of b equals 12. So the same idea right here. If you square root 7 and then you square it, that's going to undo, and you're just going to end up with 7. Okay, so 7 plus x squared, same idea right here with this 19. If you square root 19 and then you square it, you're just undoing those two, and you end back up with 19. All right, so now let's go ahead and subtract that 7 from both sides, and we get x squared equals 12. So to get x by itself, we need to square root both sides. And you can simplify the radical there. I'm just going to ask you guys in my class, all you have to do is just tell me the decimal approximation. So x ends up being about 3.46 when you plug in the square root of 12 in a calculator. And you do need to know how to plug this stuff into a calculator, so if you're not sure how to square root numbers, come find me, I'll help you out. All right, let's look at an example involving area. So if you recall from way earlier in, I believe it was chapter 1, we calculated the area of a triangle by taking 1/2 of the base and then multiplying it by the height. So when you look at this triangle here, you kind of have to think of it spinning it around this way. So your base is actually the 4 centimeters that side. So I'm just going to flip this over to kind of make that happen. All right. And you can turn your paper if you'd like to, but just FYI, this part right here is the base, and then this is our height. Okay. So when we do this, you're going to need to be aware of that. All right. Okay, so now that we have that cleared up, what we're going to do first is we need to figure out the height. We can actually, as you can see here, we can find the length of the base, because that's this whole length here, which would just be 4 plus 4, so this is 8 centimeters. Now let's call this here height. We don't know how tall this triangle is. But if you notice right here, half of this triangle is a right triangle. So we can use the Pythagorean theorem to find that h. So we'll set up our leg squared plus our other leg squared equals the hypotenuse squared. So this ends up being 16 plus h squared equals 144. So if we subtract that 16 from both sides, these will cancel, and we end up with h squared equals 128. And if we square root that, we end up with our height of about 11.31. All right, so now we have our height. Let's go ahead and calculate the area using that. So our area is 1/2 the base, which is 8, times the height, which we just calculated, is 11.31. So half of 8 is 4, times 11.31 is going to give you about 45.2 square centimeters. All right, so that would be the area of that triangle. All right, so in this last example, you're going to have to channel your inner artist because we are going to draw a picture here. So we have that a 25-foot ladder must be set 6 feet from the base of a house. How far up the side of the house will the ladder reach? All right, so let's just suppose here we've got this side of this house here, and I don't know why this house is hot pink, but we won't worry about that. And we are going to have this ladder, so I'll make that gray, why not? We got this ladder leaning against the house here, and we'll assume that this is a right angle right here. All right, so we got this situation going on, and we know that the ladder is 6 feet away from the house, so that right there is 6. We also know the ladder is 25 feet long. So we're trying to figure out how far up the house it reaches. In other words, we're trying to find the leg of this right triangle. So I'm going to call it A just to keep things simple. So we have A squared plus 6 squared equals 25 squared. Or A squared plus 36 equals 625. So let's go ahead and subtract 36 from both sides. And we end up with A squared is equal to 589. And then we can go ahead and square root both sides, and you'll get a value of about 24.3 feet. All right, so I hope this was some review for you guys. A lot of this stuff you've probably seen. Maybe this example where we had to square root a square, maybe that was a little different. But for the most part, we've used this in this class before, so I'm hoping a lot of this is review. But if you do guys have any questions, make sure you comment down below or come find me. I'll help you out. And we will see you guys next time. All right, take care.